2.0, so fully free to use for you in any commercial, non-commercial settings. You can contribute to it, you can commit to it, change, modify, whatever you want to do. Check out AWS Labs, fairly interesting if you're a developer. All the tools and services, we get integrations to it. All right, one interesting way of using Kinesis is to tap onto another open source project called Spark. Anybody familiar with Spark? Not so popular here, we get heavy R users. Okay. There's an R extension for Spark called Spark R now, which is fairly interesting. Why do I bring up Spark? Because if we talk about big data, we talked about something like Hadoop, and how Hadoop can build a cluster for us, and we don't need to worry about scale, right? You can just have thousands of nodes potentially within that cluster. You will find that Hadoop doesn't perform so fast though. Why? Because when it does what they call MapReduce phases in between, it has a shuffle phase where it needs to write things onto the hard drive. So that slows down the entire process a little bit. So one team from UC Berkeley wrote a paper around how you could build something just like Hadoop, but do it in memory. And the result of that was then Spark, which is basically an in-memory analytics cluster. How does it do that? It leverages on something called RDD, which stands for Resilient Distributed Data Sets. So it's basically just a way of having data stored resiliently across multiple machines within their memory, and be aware of things like data locality and so on to further optimize it. Bottom line is, if you compare Spark operations to pure traditional Hadoop MapReduce, you'll find it's about 100 times faster, which is pretty impressive. This can be used together with some libraries. So Spark itself just gives you Java Scala language to kind of operate on your data sets. It also has interesting projects like the MLib, which is basically the pilot kind of integration into Spark. It also has integration into R. This is still early days, but I think it's going to be fairly interesting in the future. So if you want to say I want to run an R program across a big cluster of Spark to optimize it, that's an interesting way. And it also has something called Spark Streaming, which can be used to work on real-time data processing streams, and that has a direct integration into Amazon Kinesis. So let's say if I would, for example, I'm going to demonstrate that later, I'm going to use Kinesis and I'm going to feed it with a Twitter stream, for example. If I want to say, find me all the tweets, with a certain text, let's say open source, for example, and count me those over the past 5 seconds, something like Spark Streaming can work on those windows and do so in a cluster. So even if that stream would be massive, it can just scale out, do it fairly fast. Now a count operation is fairly simple, but there are more complex aggregation methods that you can call with Spark too. Now, when we process data, I wanted to highlight one other Amazon Web Service which is fairly interesting. It's one of our newer edition, which we launched last year during our reInvent conference. AWS Lambda is basically a way of running your code in the cloud, fully managed, based on events that are coming in, and you don't need to worry about any service. So you just put in your code, and you can run your code. Now, when I say that, you're going to say, well, that just sounds to me like an application container. Well, it can be used that way. You can just put your code and invoke it. But the more interesting part is, this code can also be triggered through event changes or state transitions within your AWS environment. So you have, for example, things like S3, where you can put files in, or DynamoDB, which is a NoSQL database. You can react upon new items. So if you put a new file into your S3 bucket, an Amazon Lambda function is automatically triggered and runs your code on it. If somebody writes a new item into your NoSQL database, a new item inside triggers a Lambda function, does something with it. It also integrates into Amazon Kinesis. So whenever there are new events in the Kinesis stream, it triggers a Lambda function with your own code to work on that event. And you wouldn't need to worry about availability or scale. So we fully manage this across multiple availability zones, and we scale it up to match any kind of event throughput rate that you have. Right? If you want to throw 1 million events per second in there, it's going to get executed 1 million times through Lambda. The good news for you, because then you're going to ask me, well, isn't that expensive? No, because it's actually much cheaper than a lot of our other compute services, in the sense that we only charge you for execution time. So you can put your code, if it's not getting executed, it costs you 0, nothing. We only charge you for the actual execution time. You run the code, how long did the CPU process it? That's the execution time, and we charge you only for every 100 millisecond of that compute execution time, which is fairly interesting. Available right now for Java 8 and JavaScript, so all your Node.js stuff would work on this, and we're also looking into having further other programming languages that we can leverage with Lambda. This is fairly interesting to connect with some of our services. What are some of the things that we could do with it? I would use Lambda to clean and massage my incoming data. If I do log rotations and I put log files into an S3 bucket, then you can create a trigger. Every time a new log file is in my S3 bucket, call that Lambda function. The Lambda function could open the log file, maybe it's a zipped log file, unzip it, do some single aggregation, push it somewhere else, massage it, remove things that you don't want to have. A great way to kind of also say, I want to load things into my data warehouse periodically as they appear. Lambda could be used for that. Every time we dump a new log file into an S3 bucket, Lambda function loads it up, puts it into your data warehouse. Redshift is one example. You can obviously put it in any system you want. You can write your own code. And the more interesting part is, together when we talk about real time, together with Kinesis, every time there's a new event that comes in, that code is executed so we can work on that event. And we're going to try that later with a demo to kind of find hashtags on the Twitter stream. And since this is an R meetup, you can also run R in AWS Lambda. And I normally don't show this, but I figured it would be fun to do that here. There's a cool blog post that demonstrates how you can use JavaScript to run R. Because basically what Lambda does, it is a container. And within that container, you have all the normal Linux libraries available. So you can actually run R through it, because R is part of it. So what you can do is you could write and just say, very simple R function here, where I say I plot something out, for example. I call it say hello. You could store this as your test1.r file, for example, and then your Lambda function could look something like this, where you just say execute that file. If it was successful, do something else. Now, let's think this through. This is obviously just, it looks like just a proof of concept, but this could actually be used in an interesting environment. Thinking about the idea of rotating your log files into an S3 bucket, right? This could trigger a Lambda function, picks up that log file, and then, for example, creates a report with R, plots the information out of that log file, puts the output back into my S3 bucket, right? So that it's now a PNG file that I have readily available for me to look at, for example. And then that's fully event-driven. So no cron jobs, no scheduling, no servers. It's just fully event-driven, and you only pay for the execution time on it. So even if you say, I don't write JavaScript or Java, might have a look at Lambda, can be quite useful. This is the URL if you're interested, with a complete walkthrough on how to actually run a little R function within Lambda. Now, obviously, this is not useful if you want to run a very complex R statistical function on it, right? That would run for a few hours or something like that. This is meant to do a quick interaction, work on something in an event-driven fashion. So just keep that in mind. Now, just moving on, just wanted to highlight another concept of NoSQL databases. So we have a service called Amazon DynamoDB, which is basically our fully managed NoSQL database. Now, before I dive into what it does, I just wanted to highlight what NoSQL databases do and the importance of it. So, first of all, Amazon DynamoDB is actually based on a paper that some of our engineers at Amazon have written many years back. which they called Dynamo. And that was kind of the first of its kind NoSQL concept. NoSQL meaning that you have a database that can handle structured, unstructured data. Sorry, unstructured data in the sense there's no schema in the database itself, but it allows to fully horizontally scale. This paper was written even before AWS existed, and the reason we've done that is because we have a retail business, right? Amazon.com, which is very popular, especially in the Western world, a little bit less here for now. What you have there is a shopping cart. And if you think about an e-commerce experience, people click through the website and they put lots of things into the shopping cart, out of the shopping cart, they have sessions running. So it's a very write-heavy application on the database. Now, if anybody of you ever managed a relational database, you know how painful it is. If you get lots of writes, that doesn't scale fairly well. All your weak replicas and slave, they don't matter because you need a master to write to the database. So the concept of DynamoDB, and which eventually led to the idea of NoSQL databases, was to say we built a database that doesn't need to have this transactional consistency, but allows us to have multiple master databases. That's what a NoSQL database allows you to do. Have a partitioning and sharding key that automatically writes to multiple master nodes and fully scale that database out. Now, if you ever ran your own NoSQL database, your own Cassandra cluster, your own MongoDB, you probably know how painful it still is to kind of still maintain that. And this is where DynamoDB becomes interesting because it takes away that pain for you. So this becomes a NoSQL database service. So you create a table and you don't worry about anything underneath. You don't worry about which server, how that's replicated, or availability. We don't put any limits on it, so it has complete seamless scalability in terms of storage. You put in as many data as you want, and you can read and write from that database as fast as you want. So you just tell us how much throughput you want to have. You want to say, maybe I just want 1 write per second. And a minute later you decide, I want 1,000 writes per second. And then a minute later again you decide, maybe I just need 100 writes per second. You can do that with Amazon DynamoDB. You can adjust the throughput all the time. And how do we charge you? Based on that throughput. So if you say, I want to have more throughput, we charge you for more. If you turn it down again, and that's interesting, obviously we charge you less than that. Another element is we use SSD hard drives.